Welcome to clickmyproject.com.
Let us discuss about the automatic facial age estimation. Let us discuss about the abstract of the product. So, estimating an human age from images is a problem. So, that has recently gained attention from the computer vision community due to its numerous application as well as the challenges that face a satisfactory solution. So, besides traditional challenges in captured facial images under uncontrolled settings such as different lighting, varying poses and expressions. So aging effects on appearance depends on many other factors such as a lifestyle. So in this process, a new automatic age estimation framework is proposed. So a single image is required as an input image of the subject of interest to estimate his age. The framework is composed of three main models. One is the core system model, the enhanced model and an application model. So these are the three important models in the framework. And then the phase AGL estimation synthesis re-render a phase images aesthetically with natural aging or reinventing effects of individual phases. So enable a phase image automatically with the exact age of the age group of the individual phases. So specifically the MDML DCP schemes exploits the first derivative of Gaussian operator to reduce the impact of different elimination and then computes the DCP features at both the holistic and components levels. So DCP is a novel face image descriptor imaged by the unique textural structure of human faces. It is computational efficient and only doubles of cost computing local binary patterns. So it is extremely robust to pose and expression variation of the process. So finally we calculating the age by automatic phase AGL estimation of the process. Let us discuss about the flow diagram of the process. So these are the overall flow diagram. So first of all we get in the input image. So in the database we getting the input image and then pre-processing step and then phase reduction and extraction and then feature extraction, finally get the calculation of the process. First of all the input image. So in the input image there are many type of images, that mean various age estimation of the process calculating in the dataset. So in the pre-processing step we calculating the image resize and image Gaussian and filter of the process, and then phase reduction and extraction we apply the implement the Euler Jones, and then phase extraction we calculating the LBP and canning, and then classification we using the KNN classifier. So first of all the pre-processing step. So in the pre-processing step we remove the noise of the images by using the Gaussian filtering of the process, and then image resize. So the image will be resized, all the images will be resize absolutely 256 cross 256 of the process. So and then the phase reduction and extraction we using the Euler Jones. So Euler Jones object reduction framework is the first object reduction framework to provide competitive object reduction rates in real-time purpose. So although it can be trained to detect the variety of object classes, it was motivated primarily by detecting the phase of the problem of the process, and then it should be calculating the feature extraction. So here we using the feature extraction process LBP and canning, so least binary pattern, and then canning. So when the input to an algorithm is too large to process the data and it is suspected to be redundant, so then it can be transformed into a reduced set of features. This process is called a feature selection of the process. So the selected features are expected to contain the relevant information from the input data so that our desired task can be performed by using this reduced representing instead of a complete initial data of the process. So in the canny it can be S deduction of the process to detect the edges of the face to automatically define the face and the age estimation of the process. So finally we calculating the classification. So in the classification process which ages will be deducted for the particular images. So that is a classification process. So in the classification process here we using the KNN classifier. So that is a K means nearest neighbor classification. So calculating the age particular image. For example this age is 18 or it should be 30 age. So and this girl is identified as a 16 age. So this is the classification of the process by using the KNN classifier. So these are the overall flow diagram of the process. Let us discuss about the running procedure for the process. So click the new file and then run. So it has some time to display the process. So here we using so these are the data set. So data set we calculated the which images will be calculated. So I will click that images this image I will calculate it. So click open and then it will be the process. So all the process it will be dependent of the process. Yeah, this is the input image. We will select the input image. So this is the one girl. So this is, first of all, the face will be deducted. So this is the input image of the process, and then this is the filtered image. So in the filtered process, so the Gaussian filter by using the filtered image to remove the noise of the process. So first of all, we select the input image and then filtered image. So filtered image, the noise should be removed by using the Gaussian filter of the process. Yeah, and then deducted face image by using the LBP and Canny to deduct the face of the input image to estimate the age of the process. So this is the deducted face image of the process. The box will be deduct the face only. So identify the age, what age the person it should be presented on the process. So this is the deducted face by using the LBP and Canny of the process. Yeah, this is the next figure. In this next figure, we are applying the canning for deducting the age. So it would be this age of the person. So like that. So deducting the person of the age. So the lip, eye, and nose and mouth. So here, so all the faces will be deducted by using the canning. So the age will be deducted on the overall face of the process. Yeah, finally is deducted. So the deducted age is 15. So that's girl. So that's the input girl. So the input girl presented while the age is deducted by 15. So here there's the girl age is 15. So this is the facial age estimation of the process. So finally we calculating the performance analysis. So in the performance analysis we should be calculated the estimation of the process. So MSE, click the MSE, this is the MSE value, and then PSNR, peak signal to noise ratio. So that is a fine 45.2913, and then mean, so the mean of the process, and then intensity. So intensity will be detected some age. So whatever it will be calculated, it will be displayed. And then entropy. So finally the entropy will be calculated. So the finally estimated of the process, MSE, PSNR, mean, intensity, and the entropy. So these are the overall running procedure for the process.
Thank you for listening this video.